Hi, welcome everybody. Thanks for having me. Have we got the sound on? Because I'm going to be playing some things. That is up. Great. I'm an ecologist, not a soil scientist, so I still feel a bit of an outsider here, but hopefully by the end of the talk you'll see why. And before I start talking, I'd like you to listen to something, hopefully. That's the sound of soil, if you've never heard it before. Yeah, and my definition as an ecologist of what a healthy soil and soil health is one that produces lots of sound and varied patterns. And I come from an ecology background, and I'm an acoustic specialist, or have been for the last few years. And like my colleagues, we use sound recordings taken from the environment to understand what's going on in ecosystems. And we've been doing that in marine environments since at least the 1970s, if not before. And consultant ecologists like myself use this sort of approach for recording bats as well, and have been doing that for the last 20 or 30 years as well. But those tools and techniques that we've used for those two particular sectors have started to be widened out in the last 10 or 20 years. As we've gone through the digital revolution, we've been able to take more and better quality sound recordings from the environment and use those as a form of ecological data. And we can do that within fresh waters, although that's not done very often. We can do it for recording invertebrates above ground, whether that's crickets and grasshoppers, or record bats and birds. And in the last couple of years only, we've started to take that approach and apply it to try and understand soil ecosystems as well, because there's a whole range of invertebrates below the soil that make sound, either incidentally or intentionally, and we can take those recordings and use them to understand the ecosystem we're dealing with. So for the last couple of years, myself and a few other people around the globe have taken this approach, and it's still a very new developing field. There's less than 10 scientific papers published globally in the last few years that have used this sort of ecosystem, this soundscape approach, and applied it within the soil. And we've been using it for some conservation-based research. There's some work that we've done in the UK, some work that's been done in the Amazon, Scandinavia, and now Australia as well, where we've taken this approach. And with colleagues in the UK at Warwick University, we've been running a DEFRA, or UK government-funded project for the last 18 months to try and apply this new approach to agricultural setting as well, and understand soils and soil sounds within agri-fields. So the pictures I showed you before is a picture of sound that we use within ecoacoustics, and it's basically a graph. We have time along the horizontal axis, frequency from low, deep, bass at the bottom of the graph, and then higher frequencies up to the top. And we can use these spectrograms, as they're called, within artificial intelligence, within machine learning, for example, by producing a picture of the sound that we recorded, and then use image analysis techniques to analyze those, try and find differences with them, and use them to identify birds, if we're interested in birds, or whales and dolphins, or invertebrates such as Coleoptera larvae. I'll play you another sound. Sounds like creeping up on you, doesn't it? So not quite as beautiful to listen to as a nightingale singing in an evening forest somewhere, but useful ecological data. And say there are a small set of invertebrates that stridulate like underground crickets and grasshoppers to communicate with either other individuals within their species or to try and warn predators off. And we can record those signals, use them as a data source, a data point, and there's a little bit of research that's shown how we can use those. So, first one, back 1996, the graph on the left-hand side here is taken from stored grain. So it's not from soil, but is from stored wheat, I think it is, and they recorded sounds like the ones we've just been hearing and counted up the amount of invertebrates that were present within 1 kilo of stored grain and found a pretty good relationship between the number of sounds produced and the number of animals there. So we can relate these signals to counts of individuals and use them to measure abundance. Another one within soil settings showed the one with the pinkish box around it. This was a grid of sound recordings taken across a field, and they've measured the number of sound events that go on at each location, interpolated those to create a surface, and then they've done the same and counted the numbers and diversity of invertebrates across the field as well. And you can see, if you use your imagination slightly perhaps, that there's a pretty good relationship between the numbers of sounds that we're recording and the diversity and abundance of invertebrates that we're getting. So a couple of papers there from quite a few years ago that started some of the interest in this. However, as I said, these days we have better tools, better recording equipment, and better analysis techniques. So nowadays we can record invertebrate sounds in a range of different diverse environments, soil included, try and identify species that are producing sound in that, and then use machine learning approaches to try and count those. So whether we're looking for pests or beneficial species, or trying to assess the overall species assemblage, we can use machine learning approaches to do that sort of processing. And as I said before, we record the sound, we produce a picture of the sound, and we put that through a machine learning model to pick out new examples in new data collected from different places. So we're currently doing that with about 2,500 recordings we've recorded across the UK over the last couple of years, and trying to develop machine learning approaches to help us analyse the sound we've recorded. Another approach that we're using as well is not to bother to try to identify anything, but use an analytical approach called an acoustic index. And these have been used in tropical and temperate rainforests, in coral reefs, and we don't try to identify different species, but we just analyse a sound file to come up with a complexity score for that. And the more varied the sound is from second to second, and the more range of frequencies that are present, we give that a high score, as we can see in the top of this graph here. While if there's not much going on, or if the sounds are very boring and monotonous, we give that a low score. And this has been shown that if we measure these through the course of 24 hours a day for weeks on end, we can analyse these really simply and quickly, produce these acoustic index scores, such as 49.22 and 29.01, and relate that to the species diversity that's present in that area. Quite easy to do, and you can see that we find differences in the sound types. When we do this within soil, graph we produced is on the right-hand side. A guy called Marcus Mader in Switzerland published his paper in 2022 where he took recordings, analysed them using an acoustic index approach to give a score, but also took a soil core out, funneled that in the lab, and counted the diversity and number of invertebrates that were present in the soil core next to where the recording took place, and found that taxon richness within the soil fauna is related to this acoustic index. If we do those recordings over the course of a day or through seasonal patterns, we can identify that there are patterns in the amount of sound energy, sound activity that's produced there, so that within the UK or temperate European settings, things tend to be quiet overnight, but as the soil warms up during the course of the day, we get more invertebrate action going on, more sound produced, and so we can see in these graphs here that through the full 24-hour cycle, we get a cycling in the amount of sound activity that we get, and we get the same thing over a seasonal pattern as well. So for the last 18 months, we've been working on this farming innovation program funded by UKRI, and we have been developing a prototype for a soil recording device, not called a Bob, it's called a Sam, I kid you not, developing a pretty large sound library for soil recordings within agricultural settings and developing algorithms to help us analyse those. So we've covered a lot of farms across England, especially 70 plus farms, recorded over 2,000 soil recordings, and we've developed a traffic light system where we can analyse the sound using an acoustic index, give it a score, and use this grading system to put new recordings into context. So if a farmer goes out with a recording device, he knows whether it's a good, bad, or indifferent level of sound activity related to soil health. We've also been doing replicated trials. This is Rothamsted research in the UK, which some of you might know, with large replicated land use trial plots. So this is plots of bare ground and different sorts of arable production, permanent grassland, and if we compare the sounds that we're getting from different plots, we can see that bare soil and winter wheat over the winter doesn't produce much sound, while some of the more varied, interesting habitats in terms of the above ground cover give us higher sound scores. We've also been doing some fairly detailed work with worms in buckets, complicated mesocosm setups, looking at different numbers and functional groups of worms in different soil types, recording those to try and understand some of these specific sounds, and trying to build up a big picture of how we can use this sound recording technique to look at land management. As I said, there's been work being done in Switzerland and by ourselves in the central UK, and also repeated in Australia. So in different environments around the world, we're finding that if we record sound in different habitats with different habitat conditions, we can relate the sound characteristics, the soundscape in that, to the level of habitat quality we get. And that is also related to the invertebrate abundance and variation that we get. So, also coming out next summer, as well as Bob, Sam will be released into the wild as well. We've currently got a Kickstarter that's started in the last couple of days, which is a farmer-friendly or land manager-friendly sound recording device that allows you to plug a microphone into the ground, press a button, take a recording, and then upload that to our analysis website. That will give you an assessment of the sound quality in the field that you're looking at and relate that to the overall soil health in the area. So keep an eye out for that next summer. Thank you very much.